Can a computer understand mathematics? Let's take an example. Russell's paradox is a famous piece of mathematics that's also short enough to use as an example. It's written so briefly here that many mathematics students would have trouble with it, so let's write it up more carefully. This is a careful proof of Russell's paradox in a natural mathematical language, written in the free software Lurch that I want to introduce to you today. So, can the computer understand this? It's not written with the level of formality you'd expect a computer to need. Computers, after all, do not speak English with the precision required for mathematical arguments. So let's give the computer some hints. This mathematical expression here has been marked as an expression, giving Lurch the hint to pay more attention to it than to the words around it. We've told Lurch where an important piece of meaning is, some math instead of just words. This symbol has been marked as a premise, giving Lurch the hint to find something with the same mark, up here, and consider it as a premise when evaluating the previous statement. From little hints like these sprinkled throughout a mathematical proof, Lurch can infer larger structures as well. When our cursor is here, Lurch shows that it understands this block of text as a subproof within the larger proof. You can see that it goes from the initial assumption, which was towards a contradiction, to the discharging of that assumption using a contradiction. If I move the cursor up, we see that there are even subproofs within subproofs. Does this mean that Lurch is really understanding this whole proof? Before answering that, think about what it would mean if the answer were yes. Students learning to do proofs would have a free tutor always available to check their work and give immediate feedback on every single step of it. Lurch would be a powerful educational tool. So I'll ask Lurch to grade the steps in this proof and we'll see if it understands. Here's the button for Show Validation Results. The green lights mean that Lurch judges every step in this proof to be correct. That's because I was careful to choose a correct proof as my first example. But what if I change something and make a mistake? Here, let me delete this premise marker, or just change it. Lurch takes a second to reread my work, and not only marks the previous statement incorrect, but it also marks the original assumption as undischarged. So Lurch is showing me with this yellow light that this assumption hasn't been used anywhere in my proof. So let me fix it by putting my star back, and Lurch will take a second to reread my proof and notice the change, and then mark the final line correct, and then the initial assumption as discharged. Each red, yellow, or green light can be double-clicked to get a report on what's right or wrong and help you learn how to fix it. Imagine how helpful it would be to do proofwriting homework in Lurch. Lurch is very customizable to the needs of a particular course or textbook, and the version in this video is released at the end of June. Check out our other videos to see more of the user experience, or download it and try the built-in tutorial.